Hi. You cannot open an application today without them claiming that it has been run by AI or driven by AI or something like that. So it's everywhere. But do you honestly really know what it is? In this video, I'm going to explain to you what AI is and how it can be used in a business context and why it can be used to solve problems that is different from IT problems. My name is Per Damgaard. I've been working with AI since 2015, where I took my first AI patent. I've started two AI startups and written a book called AI for CEOs. So I'm very passionate about AI, and I hope that you are able to learn a bit about how you can use AI in your daily life today. So to get started, it's always good to define what AI is. And of course, AI is a topic that is used in many different contexts, so there's also a lot of different definitions. And the one that I like the best is that AI is non-human intelligence. And non-human intelligence, that's a pretty broad definition, and maybe it's a bit philosophical, but I like it because of its broadness, because AI is actually pretty broad and can be used to many things. So think of it as something intelligence, and intelligence means making decisions that is made not by a human but by something else, a technology. A bit abstract, I know, but we'll get more into it now. Before I start the really interesting part, and that is why AI is different from IT and why AI can be used for different use cases than IT can, I think it's important just briefly to touch upon the definitions of AI, because you've probably heard them before and they're sort of used together, but it's nice to know a bit about what they are. First of all, you should think of it like a sample of elements, like in many other areas of life. AI is the broadest definition of this technology, and then you will have sub-branches within this and different angles. And there are many of those, but the most used ones are the ones called machine learning and deep learning. And machine learning is a very interesting and very used element of AI, because it makes a decision based upon pattern recognition. And this principle can be applied in many different areas, and we'll go into this in more detail later. But basically, pattern definition is that you have a data set that consists of a lot of different elements, and then your AI algorithm is able of identifying patterns in these elements, and based upon this it can say that what I'm seeing now is a horse, or what I'm seeing now is a number 3, and stuff like that. And that is the core features of machine learning. And then you have a sub-branch within machine learning called deep learning. And deep learning is actually a next step or next level of machine learning, because deep learning is capable of making itself better. Because deep learning basically is running the same way as machine learning, but then it learns from its experiences. So it will start being able to identify a horse, and then learning as it go along, it can be more sharp on maybe what kind of horse it is, the sex, and so on. So it teaches itself and improves as it go along. So that's pretty fascinating. And not so many technologies has reached the deep learning state, but a lot of the applications that you're using is based upon machine learning principles. Okay, so before I continue and let you in about what makes AI smart, then I'll just let you know that as you might have noticed, I'm speaking to you using a presentation. And if you would like, then you can download this presentation either as a PowerPoint presentation or a PDF on our website, and you can find the links in the description underneath here. So just the service information. Now getting back to AI and why AI is smart, and why AI is something different than IT, because that's important for you to know. I think all of us have a conceptual idea about the kind of problems you can solve with IT, and a general understanding of how IT works, not from a tech point of view, but what can IT be used for. We also have ideas about this. And there's a big conceptual difference between the sort of problems that you can solve with IT and the sort of problems you can solve with AI. So they actually complement each other. So it's not something that you should expect that within 10-15 years or something, then all IT solutions will have become obsolete and everything will be AI. They would work together. Some problems are better solved with IT, some is better solved with AI. But it's two different ways of solving problems from a tech point of view. And I'll just let you know a bit more about this now, because we have to talk about what makes AI smart. To do this, we go back to what I mentioned earlier about pattern recognition. And at that point, it might sound a bit abstract. So now we dig a bit deeper into it so you can get an idea about why this is actually pretty smart. And the reason it's smart is because AI works in many ways the same way as the human brain does. And I'll get back to that very soon. If you look into this presentation here, then you'll see something on the screen. And it's not very clear what it is. So you can make some deductions about what could it be. Could it be, of course you can see it's a shadow, but what's behind the question mark? Is it like some sort of monster from a science fiction movie? Is it a seahorse? Or could it be an old man? Actually, it's none of those elements. It is a shadow dancer. And conceptually, AI works in the same way. AI makes decisions based upon what it can see, and then it can recognize that, okay, I've seen something like this before. What I'm seeing now is very much likely the same thing. And that's why people talk about training AI. So what you're doing basically is that you're collecting a lot of data information points, and then you give these points to an AI algorithm, and then you say to them, this is a car, this is a bicycle, this is a man, and then you continue, and then the AI would identify elements of those pictures or whatever you show them, and then it would learn to distinguish what makes a car. But it's not something that can be articulated in rules. It's something that is best understood by putting dots together and putting weights upon those dots. So that's actually what AI is doing. It's building some sort of calibration picture of what makes what it is seeing defined as a car or defined as a shadow dancer and so on. So AI in that way doesn't know when it sees a car that it's a car, but it knows that what it's seeing is a car because it has seen 10,000 cars before and they look like that. So AI is not smart in that way. It's not like AI, you hear examples of AI can help cure skin cancer because it can detect moles that has cancer faster and more efficiently than a dermatologist can do. And that's not because AI is smarter than a dermatologist. It's because AI is very good at detecting patterns, and it can see patterns that is specific for cancer moles that the human eye cannot see. But AI doesn't know anything about cancer or moles as such. It's just very good at making those distinctions. So AI is not smart in that way. AI is smart as making decisions that can, in some ways, be better or more precise than human decisions, and also better and more precise than IT decisions. I'll get a bit more into that later. So for now, just remember, AI is like a calibration task. You have a lot of data points, and then the AI is trained, and then it will know things. Again, a bit abstract, because how is that usable for you as a business? That's sort of on a very conceptual level. What can you use it for? And actually, you can use it for different things. Looking at this picture here, this is a number of threes. And everybody, when you look at this as a human, you don't question whether or not this is threes. It's very obvious when you look at it. It is because since you've been 3 years old, you have known how a number 3 looks like. You can't articulate what makes a 3, but when you see it, you just, based upon your intuition, knows that this is a 3. And it's the same way with AI. AI is also capable of being able to identify a number 3, not based upon rules, but based upon it has seen a lot of number 3 written different ways. So it knows that it's a 3, but it can't explain why it's a 3. And why is that then important? And that's important because the decision-making process and the kind of problems you can solve with AI is different than the kind of problems you can solve with IT, and the problem solving flow is also different. And to illustrate this, I like to use an example. Let's say that you want to determine what kind of clothes you're going to wear today. And that would be based upon what the weather would be. So you live in a house and you have a weather station. And this weather station, of course, monitors different weather elements. It would monitor the temperature, the wind direction, the humidity, and so on. So based upon this, you should then be able to decide whether you should wear a t-shirt or not. And IT can help you make this decision in a rule-based way, but AI can also make you help this decision on a knowledge-based way. And to make you understand what the difference is and why that makes AI in some ways smarter than IT, I would like to use a concept called the knowledge pyramid. And the knowledge pyramid is basically a way of putting more information into data. It consists of 4 different layers. The first layer is the data layer. And that, going back to the weather station example, would be all the data that you collect from your weather station. So there'll be a lot of numbers. So anybody who's presented with these numbers wouldn't know what it is, because it'll just be like a spreadsheet full of numbers, and to everybody that would seem like random numbers. You couldn't detect what it is. In order for you to do so, you have to convert data into information, so that instead of 20 it says 20 degrees and the wind direction and so on, and that makes it possible to convert data into information. And when you have information, then it's possible for you as a human, because you have knowledge, to understand what this information means. Because when I, who has an academic background, looked into this data, then I would know, okay, this looks like wind data and temperature data. So I would assume that it has something to do with wind and temperature, and maybe it would come from a weather station, I would think. And the reason I can do this is because I have knowledge. And then the last element, okay, so now I understand the data. I know that it's 20 degrees outside, and I know the wind direction, and I know the humidity, so I know the chances of rain. The last point is wisdom, because based upon my information here, I would then make the decision, okay, maybe it's too risky because the humidity is too low, so I'm wearing a windbreaker today and not a t-shirt. And AI and IT can help me make this decision, but it would be on different elements, because AI would look into all these patterns, and then they would look into my behavior and see that, okay, in these conditions I would wear a t-shirt, and in these other conditions I would wear a windbreaker. So it would give me a suggestion, okay, today you should wear a windbreaker because there's a big chance of rain, knowing what I can see in the data. So AI is making the decision to me based upon learnings, and it has seen in my pattern, just as you saw before with all the points. You can also make IT make the same decision, or help you make the same decision, but it would not be based upon patterns. It would be based upon rules, like if then else. If the temperature is higher than 20 degrees Celsius, if there's no wind, then you should wear a t-shirt, if not, wear a windbreaker. So the problem with that approach is that there will always be exceptions that overrule each other, and because the complexity of the decision making that we represent here is very large, so it's not possible in many cases to define all the rules that I as a human make. In this case, I would make the decision to wear a windbreaker and not a t-shirt. But the rules or the reasons why I did this is very difficult to describe in rules. And if you can't describe it in rules, then you can't make an IT application that does so. But you can identify patterns in my behavior based upon the data that you have, that can make AI understand what I'm doing and then make the right suggestions. So that's conceptually 2 very different approaches to how technology works to solve the same problem. So the way the 2 technologies make decisions is actually why AI can be used for different use case scenarios than IT can. And AI is working to solve problems sort of the same way as we as human would do, because it's very much based upon intuition and detecting elements. You don't have to articulate exactly how the problem can be solved using rules. It's more based upon learning and experiences, which is also why, as I mentioned earlier, you train the AI to know how things work. This makes it possible to apply AI into cases where it would never be possible to solve the problem with IT, because the complexity of the environment that you look into makes it impossible to define the rules that IT would require to solve the problem. That's not the case with AI, because AI learns how things work, and then it can make decisions very fast based upon that. And that's the reason why AI is smart, and why AI can be used in many different cases, because AI in many ways simulate the way we as humans work. And of course, in many cases, it can be done faster and more efficiently, because it can process data faster than we can. So that was sort of an introduction to how AI works and why it's smart. I hope you found it interesting. And if you'd like to know more about topics like this, and how AI can be used in your business, then subscribe to this channel. As I mentioned earlier, you can also go into our website. You can find the link below here, where you can download the presentation that this presentation has been built upon in either PDF or PowerPoint format. So you can use that for your own presentations if you need so. I hope you found this interesting, and thank you for watching. Bye bye.